Good morning. In this session, we are going to see a topic on boundary layer over vertical plate. The heat conduction equation are derived by using a energy balance on a differential element inside the medium, and we have not considered any information related to the conditions on the surface, which suggests the surface temperature or specific heat flux. But we know that the heat flux and the temperature distribution in a medium depends on conditions at the surface. Without the description of the thermal conditions at the surface, the description of the heat transfer problem in a medium is not complete. A heat transfer in the presence of fluid motion on a solid surface, such as a diffusion generation and the physical transport of the fluid conduction of the fluid due to directly contact which does not move to the hence the heat transport to the fluid is conduction is only. Convection. There are two types. One is a free air natural convection and forced convection. The free air natural convection is included by a buoyancy forces, and the forced convection is done by a driven externally. Both may occur with a phase change, that is a boiling or condensation. The heat transfer rate Q is equal to H into Ts minus T infinity. The H is a heat transfer coefficient. The convection rate equation. The expression shows in order to determine the H, we must first determine the temperature distribution in the thin fluid layer that coats the wall. The classes of convection flows, it is extremely diverse, and there are several parameters involving the systematic parameter approach required, and the classifiers are non-dimensional numbers. Need to understand the physical behind each phenomena. The classifications are based on geometry and driving mechanism and number of phases and the natural flow. The geometries are external flow and internal flow, and the driving mechanism are natural convection, forced convection and mixed convection, and the number of phases are single phase and multi-phase, and the nature of flow is a laminar and turbulent. How to solve a convection problem? The solving governing equations along with the boundary conditions, it includes a conservation of mass and momentum and energy. In conduction problems, only 3 is needed to be solved, hence only few parameters are involved. In convection, all the governing equations need to be solved. The large number of parameters can be involved. It is a diagram for laminar and turbulent flow, and the Nusselt number formula, it must need of Nusselt number, Prandtl number and Reynolds number. The Nusselt number formula is Hx by K, that is a convection heat transfer strength by conduction heat transfer strength. And the Prandtl number formula is V by, that is a momentum diffusivity by thermal diffusivity. And the Reynolds number is Ux by V, the inertia force by viscous force. The forced convection. An external flow is surrounding by a solid boundaries that can resist the development of boundary layer, for example a pipe flow. An external flow on the other hand are flows over a bodies immersed in a unbounded fluid so that the flow boundary layer can be grow freely in one direction. The momentum balance, inertia force and the pressure gradient, the viscous forces and body forces. The energy balance, the convective flux, diffusive flux and the heat generation and the energy storages. The hydrodynamic boundary layer. One of the most important concepts in understanding the external flows is the boundary layer development. The hydrodynamic and thermal boundary layers. As we have seen earlier, the hydrodynamic boundary layer is a region of fluid flow near a solid surface where the flow patterns are directly influenced by the viscous drag from the surface wall. The thermal boundary is a region or a fluid flow near a solid surface where the fluid temperature are directly influenced by the heating or cooling from the surface wall. This is the effect of Prandtl number, and the boundary layer equations of a laminar for a conversion of mass and momentum and energy. And the boundary layer thickness formula, the skin friction coefficient formula is given. The forced convection over exterior bodies. The much more complicated, it is a much more complicated. Some boundary layer may exist, but it is likely to be covered, will not be constant. The boundary layer may also separate from the wall. Flow over a circular patterns. The flow patterns from cross flow over a cylinders at a various Reynolds numbers. It is an internal flow. It is a heat transfer. Consider the total thermal energy carried by the fluid. Now the image has the same amount of energy is carried by a body. Fluid the same mass flow rate but a uniform mean temperature, that is a Tm. It is a free convection. It is a formula for Grashof number and the Rayleigh number. Thank you.